Very good morning to all of you. Today I want to start experiment 11. The title of experiment 11 is given determination percentage of chlorine in bleaching powder. Title of experiment 11 is determination percentage of chlorine in bleaching powders. Okay. Course outcome of this experiment and this subject is prepared here. There are 4 course outcome. First one is acquire capability to conduct experiments and estimate the concentration of different parameters. Second course outcome is compare the result with standards and discuss based on the purpose of analysis. Third outcome is determine type of treatment, degree of treatment for water and wastewater. Determine type of treatment, degree of treatment for water and wastewater. Fourth outcome is identify the parameter to be analyzed for the student project work in environmental stream. So these are the 4 course outcomes are prepared based on the title of the experiment as well as based on these subjects. Title of subject is Environmental Engineering Laboratory and that subject code is 18CVL67. This comes in 6 semesters of civil engineering departments. Let us see, these are the apparatus and equipments are used in the environmental engineering laboratory to conduct any type of environmental engineering related experiments. These apparatus and equipments are continuous we are using. So without these apparatus and equipments we are not able to complete the given samples to get the results. So that's why you should be carefully, neatly you handle these apparatus while doing the experiment in the lab. Now let us see concept of bleaching powders, okay, of this experiment. Bleaching powder is used for disinfecting public water supplies. Bleaching powder is used for disinfecting public water supplies. It normally contains low values of chlorine such as 25 to 30% and is an unstable white powdered compound. It goes on losing its chlorine content when exposed to atmosphere. It goes on losing its chlorine content when exposed to atmosphere. Its strength should be therefore first be ascertained in the laboratory before using it for chlorinations. So that's why you should be remember this is the basic concept and backgrounds of bleaching powders to use in the experiments. Which are the apparatus are used here? Burettes are required, pipettes are required, conical flask are required, volumetric flask are required, beakers are required, spoons are required, glass rods, weighing balance, dropper, etc. required. So these apparatus are compulsory required to execute this experiment. Let us see which are the reagents are required to complete this experiment. First reagent is sodium thiosulfates of normality N/40 is used. How to prepare this sodium thiosulfates of N/40 normality? So here procedure is given. Dissolve 6.25 gram of sodium thiosulfate in 1000 ml of double distilled waters. That is freshly boiled and cooled distilled waters, that is double distilled waters, okay, and dilute. Add about 5 ml chloroform as a preservative. So this is the steps to prepare sodium thiosulfate reagents of normality N by 40. Next, to prepare the bleaching powder solution. How to prepare the bleaching powder solution? Here steps are given. Dissolve 0.5 gram of bleaching powder in 200 ml distilled water and dilute. This is the preparation of bleaching powder solution procedure. Potassium iodide reagent is required. So how to prepare this potassium iodide reagent? Here procedure is given. Dissolve 5 gram potassium iodide in 100 ml double distilled water and dilute it. Now we are getting potassium iodide. Next, you select glacial acidic acids. So this is readily available. Next, freshly prepared starch. This is also required for this experiment. So now how to prepare freshly prepared starch? Procedure is given here. Dissolve 2 gram of LR grade soluble starch. Dissolve 2 gram of LR grade soluble starch in distilled water and pour this emulsion into 100 ml of boiling water. Allow to boil for few minutes and add 0.2 gram of salicylic acid or toluene as preservative. Cool this solution and then use. So these steps you follow to prepare the freshly prepared starch. Okay. So all of you remember, while executing the experiments, reagents are most important. Without reagents, we can't do the experiments. So that's why you should be perfectly understood how reagents are prepared. So this is the first step to starting the experiment. Reagents prepared first. So to prepare the reagents, you purchase the concerned reagents, chemicals, then you prepare required normality. Next, procedures. How to conduct these experiments after preparation of reagents? Take 25 ml bleaching powder solution. Take 25 ml bleaching powder solution. Then add 2 ml glacial acetic acid followed by 2 ml potassium iodide and few drops of starch. Okay. Second step, you finish. So then after addition of Ki, color of the solution becomes dark yellow, and after addition of starch it changes to blue. So these steps you remember while adding the solution in bleaching powders in conical flask. Titrate against sodium thiosulfate till the blue color disappears. Okay, now titrate against sodium thiosulfate till the blue color disappears. Then note down volume of sodium thiosulfate consumed. This is the procedure for this experiment. See observations and calculations. So see here how to write the observations. First is in burette. So in burette, which are the reagents are required to fill? N by 40 normality, that is 0.025 times normality sodium thiosulfate solution is filled. So in conical flask, 25 ml of sample plus 2 ml of Ki solution plus 2 ml of glacial acetic acid plus 2 to 3 drops of starch indicators are filled. Then indicator is used, starch indicators is used. End point, which point we are getting at the end? Blue to colorless. So this is the observations. You perfectly, clearly, patiently you write the observations. So observation itself is the 50% procedure of experiments. So while seeing the observations, we can follow the executing the experiment. Okay. Next, tabular columns, that is tabulations. How tabulation is prepared? Serial number, second column description of samples, in third column burette reading in ml, that is first one is IR reading, second one is final reading, third one is difference between FR and IR. So then we are doing MBR, that is mean burette readings. So here while seeing this table we are doing 3 steps, that is a 3 steps is nothing, 3 trials, sample 1, sample 2, sample 3. Each sample you take 50 ml, 50 ml, 50 ml. Then you repeat the number of trials. So then you take the readings, then you do the calculations. This is the calculations. Okay. Percentage of chlorine in the bleaching powder is given by the formula normality of titrant into MBR into ml of bleaching powder solution prepared into equivalent weight of chlorine divided by ml of sample titrated into milligram of bleaching powder taken into thousands. Okay. Now here based on this formula you write the value. Normality of titrant mean 1 by 40 into MBR, you write the results from the table. ml of bleaching powder solution prepared, that is 200 into equivalent weight of chlorine 35.45 into 1000 divided by ml of sample titrate, that is thousands, into milligram bleaching powder taken, that is 25. You convert into percentage. So we are getting multiplying 100. So finally we are getting percentage of chlorine in bleaching powder. After getting the results, now you write the results. After calculation, now you write the results. Percentage of chlorine in the bleaching powder is given by this much n numbers. Okay. Now based on the results you write the comments. Now I have written one sample of comment. The percentage of chlorine in given sample of bleaching powder is found to be this percent. The fresh bleaching powder will have chlorine in the range of 25 to 30%. Hence the given chlorine is old one and cannot be used for the purpose of chlorinations. So if the result is not coming in between this range, so you should write this type of comments. Okay. Next, these are the references are referred for these experiments and these subjects to study and execute neatly. Okay. Thank you one and all. Next experiment I will continue in next class.